Okay, so here is a good looking related rate problem that illustrates how we are going to use similar triangles to solve one of these problems. Now, here we have a cone, and you can think of a cross section of a cone as if you look at the cross section like we're looking at here, you see triangles. And in fact, what you want to take note of before we even start is that we have this. We have this big triangle here, and then we have a similar triangle down here. Okay? And notice we have the big height, the big radius, and then we have this variable radius here and the variable height here. So what we have is we have a set of similar triangles, a pair of similar triangles. But anyway, that's one of the things you note. So when you're working with a cone, you're thinking, I bet I'm going to have to use similar triangles. But first of all, let's read through the problem and see what they're asking. They're saying water is draining from the bottom of a cone of the funnel at the rate of 0.03 cubic feet. So what they gave us really is the rate of change of the volume, because this cone had water in it and it's draining out. Now, water is not coming into the cone, it's draining out. So when we talk about what we're given here, we're given that the volume is changing at 0.0 cubic feet per second, but it's decreasing, right? The volume is decreasing. So that's going to be negative 0.03 cubic feet per second. Okay, so that's an important point. It matters if water is coming into the tank or going out. So be sure we understand that. The height of the funnel is 2 feet, and the radius at the top is 1 foot. And here's what we want to find. We always write down what we're given and what we want to find, and we want to find the rate at which the height of the water is changing whenever the height is equal to 1/2 foot. Okay, so what we're looking for is a relationship between volume and height in the cone, and then we'll find a relationship between the change in volume and the change in height. So here we go. The formula for the volume of a cone is 1/3 pi r squared h. Remember, it's 1/3 the volume of a cylinder. Now, I've got this problem in that I have not just V and H, I've got R in here as well. So what I need to do is I need to figure out a way to write R in terms of H. Well, that's where this idea of the similar triangles come in, because, look, we know that H is to R what 2 is to 1, right? Now, of course, it'd probably be better, since I want to solve for R, is to write this as R over H equals 1/2. And then I solve for R, and I get that R is equal to 1/2 H. Now, we didn't need to know about similar triangles really to figure that out. I mean, if you could look at that and say, oh, yeah, I see that relationship R is 1/2 the height. But anyway, now that we've got that, we could write volume is equal to 1/3 pi, but instead of R, I'm going to write 1/2 H. Yeah, there we go. Now, I simplify that just a tad, and I get 1/3 pi times 1/4 H squared times H. See, just taking it a step at a time, which that gives me volume is equal to 1/3, or let me just go 1/12 pi times H cubed. There it goes. I just went ahead and multiplied out the 3 and the 4. I mean, that's something any decent human being would do, right? So now we've got it simplified. So here we go. dV dt equals pi over 4 h squared dH dt. Remember the chain rule. H is a function of time, so we differentiate the outside. H cubed, 3h squared and then I multiplied it by the derivative of the inside, which is dH dt. At this point, we can put in what we've been given. In place of volume, I was given negative 0.03, and I'll just leave off the units because right now we're just going to be doing some algebra. I'll put in the units at the end. We've got negative 0.03 equals pi over 4 times 1/2 t squared. Now, that's not 1/2 t. I'm sorry. It's just 1/2, isn't it? Sorry about that. I don't know what I was thinking. Where'd that t come from up there? Okay, so now let's see what we've got now. We've got negative, let me just call this 3 over 100. You know, I like fractions better. Equals pi over 4 times 1/4 dH dt. And let's see what that's going to give us. That's going to give us negative 3 over 100 equals pi over 16 dH dt. Now I need to multiply both sides by 16 over pi to finish this off. So I get now dH dt equals negative 3 times 16 over 100 pi. We're almost done now. I just want to simplify it a little bit because notice that this 16 here has a 4 in it and the 100 has a 4 in it. So this is negative 3 times 4. 4 will go into 16 4 times. 4 will go into 125 times. Yeah, so look, here's what we've got. We've got negative 12 over 25 pi. Now, remember the units that we were dealing with feet. So this was, let me go back up here and see what I've got here. I've got, we're dealing with feet per second. So this is feet per second. So let me just write this answer this way. I've got negative 12 over 25 pi feet per second. And there you have it.